All right. Good evening, everyone. How is everybody? Are there any questions before we start anything?
Hi, Professor. Quick question about our project.
Yes.
We have in the notes, it says to do either a local or a national company. Can this extend to international companies if it's in an area of interest?
For sure, yeah. I don't have restrictions on the the data location. Could be international, could be domestic.
Perfect, thank you.
As long as it is time series data.
Okay.
Okay. Other questions?
I just had a quick question about the exam.
Yes.
For the first test, we weren't able to copy paste data from like the quiz to Excel. Would you be enabling that for the second test?
Thank you for bringing that up. Yes, in second test, if you required to enter data into Excel or SPSS, actually in second data, I only ask you to use Excel, but if you can use SPSS, go ahead. The way I do is I will attach Excel file on the D2L. So you download the file on your computer. Unfortunately, you cannot copy and paste from the test question, but I give you the Excel file separately. Would that work?
Yeah, that would work, just as long as like we don't have to manually enter it. For the first test, it just took up a lot of time.
Yes, and I actually will upload the Excel file. Okay, thank you. So you do not need to manually type in. Other questions? All right. So last session, we did multiple regression. It is just a general multiple regression. Today, we are going to focus on time series data for regression. So regression with time series data. And also today, we will talk about the logistic regression. This topic is not available in the textbook, but I will provide the notes. A Word document is uploaded to the D2L website. So you are responsible for also logistic regression. Okay, it is listed on the course outline. Next week, we are going to do a RIMA methodology. Okay, after next week, we will have our test 2. After test 2, we'll have 2 more lectures, then we're done for this semester. Okay, so that is the rest of term work. Just a reminder, the project is due week 11, midnight of class day, that is April the 5th. Okay, April the 5th is the project due. Any questions? Okay. So when we talk about the time series data, we always encounter an important concept, autocorrelation. Autocorrelation. For example, if you have original data plotted in here, those dots are original data. Those dots are original data. If you want to fit those data into the regression line, you might produce this y hat here. This dotted line is the y hat. Okay, and how did you get this dotted line? Remember, we use least square. Least square, okay, to produce this fitted line. But if the data is a time series data, means you have autocorrelation, this is not the true representation. This y hat is not the true representation of the original data. Actually, the true regression line is represented by this solid line here. This is the true regression line. Okay, so the dotted line could be misleading. The reason it could be misleading is you violate the assumption, one of the assumptions for regression. One of the assumptions said the errors are independent, but with the time series data, errors usually are associated with each other. When errors are not independent, you cannot use regression. Okay, is there a remedial method? This is actually one of our topics today. You can maybe add additional data, or you could manipulate original data. For example, you do the differencing or do the log, do the data transformation, okay? So that the objective is to eliminate the error dependency. Okay, after you do transformation, you check the error term, they are independent, then you can use regression. Okay, so this is this diagram. So let's go over the example 8.1. Okay, this example, let's look at the diagram first. There are two time series data. The upper one, that is the YT. The lower part, this curve is xt. Okay, so the x-axis is time, y is data. Okay, xt is time series data, has a strong autocorrelation, means the error terms are dependent on each other. Yt is a time series data. The autocorrelation exists. When you have a strong autocorrelation, that can make two unrelated variables, so xt, yt, unrelated each other. But because of the autocorrelation, they appear to be related. It is appear, you see, looks like when you increase x, y also increase. Okay, and the direction looks like they are matched. When you increase x, y increase, decrease x, y decrease. Okay, that is because autocorrelation problem. As a matter of fact, those two variables, xt and yt not relate to xt, but yt, xt move together. This is because yt, xt are highly autocorrelated. Okay, so the purpose of this example to demonstrate that two unrelated variables could appear to be related. As a matter of fact, they are not related. So this is the purpose of example 8.1. Then how do we examine we have autocorrelation? We can use residual autocorrelations. Okay, many computer programs will compute a statistic. That statistic is called Dubon-Watson statistic. Based on this statistic, we can tell, do we have autocorrelation or we do not have autocorrelation? The rule said, if Dubon-Watson test greater than DL, I will explain DL in 1 second. If Dubon-Watson test greater than a number, that number denoted as DL, DU, we conclude there is no correlation, rho equal to 0. Okay, so rho equal to 0 means no correlation. no correlation. If Duban-Watson test is smaller than a number, that number is denominated by DL, we conclude there is correlation, okay? So, and if this is greater than 0, it is positive correlation. And then there is a question, what is DUDL? DUDL is like, remember you do the T test, Z test, you have critical values. It is like the critical value, okay? And you can get this DL, DU based on this table. It is available in the textbook, okay? In this table, N represents sample size. For example, you have sample size 15, 16, etc. And K represent number of independent variables. K equal to 1, you have one variable, 1x. K equal to 2, you have 2x. K equal to 3, you have 3x, etc. That is K. So based on number of independent variables and based on sample size, as well as based on the alpha, say the alpha is 0.05. If alpha is not 0.05, you are given similar table, okay? It is in the textbook. You can look out in the textbook, alpha 0.01, but most often we use alpha 0.05, okay? So let's practice to get DL, DU. So suppose I have sample size 35. I know I have two independent variables, and I give you 0.05. I ask you what is DL, what is DU based on this table. Okay, so let's do it. So first confirm this is 0.05. This table is based on 0.05. Okay, and N equal to 35, you locate 35. And K equal to 2, you locate K equal to 2. So go down, you get DL equal to 1.34, DU equal to 1.58. This is how you use this table. Okay, any questions? All right, so now let's calculate Duban-Watson test DW using the formula, okay? So the formula said DW equal to EI, the error term for I minus the previous error term, square it, add them all, I from 2 to sample size n, divided by EI squared, add them all, and this time I from 1 to n. This is formula, okay? So let's do the calculation based on this formula. In PowerPoint slide, I posted on D2L, you can just copy this data into Excel. So select data, right click your mouse, copy, you can paste it into Excel, okay? And the other way is, this data is from textbook. You can get data file from D2L, okay? So anyway, so let's look at the calculation. So I'm going to open the Excel. This is sales, then income. All right. So sales income, okay. So I'm going to demonstrate how to use Excel to calculate DW. That is what I am doing now. This data file, it is chapter 8. You can get it from D2L. or directly get data file from the textbook data file. I also uploaded to D2L. Okay, so we need the error term. To get the error term, you need the forecast. You need the forecast. So you need y hat. So this is the sales. Okay, so this sales is my y, and this income is my x. Okay, so y correlated to x. To calculate Duban-Watson test, so this is the formula. I want to show multiple window. You need to get the equation. Okay, you go to data analysis, you get the equation. Okay, once you get the equation, you can figure out what is the y hat. So this is y hat. But there's another way I want to show you. In Excel, you type in equal trend, equal TREND, and then select Y, comma, select X. I pause for a moment. So this how you get the Y hat. Okay, it is easier than using data analysis. You have to write down the equation. Okay, you do not need to write down equation. You just type in equal trend. Wow, you get Y hat. Remember, this is Y hat. And what is the EI? Error term E. It is just the error term E, it is just the residue, the difference between Y and Y hat. So this is Y, 295, minus, this is Y hat, that is EI. I pause for a moment. Who can see your message? Oh, no questions here, okay. Any questions? So I get EI, okay. And then copy down to calculate EI for all Y. This is the EI in the formula. Original Y minus predicted Y, that is EI. Now I'm going to do the formula has EI minus 1. EI minus 1. So I minus 1, that is the subscript. I have no way to type in subscript, so I'll use this one. Hope you understand. Because I have I minus 1, so I got to start with second cell. Okay, I got to start with second cell. So equal, this is E2. E2 minus E1. E2 minus E1, and then you copy down the formula. The general form is EI minus 1 here. Okay. All right. So negative 47 minus negative 76, you got positive 28. So copy down. So you have EI, E minus I. See the formula here? So hope you understand this term, EI minus, or haven't, so next one, I'm going to do EI minus 1. Okay, so I don't have the first term for EI minus 1, so I start with second one. So equal, this is EI, you agree, minus EI minus 1. Okay, any questions? And then copy down the formula. So I got this term here, EI minus 1. But I also need to square it. See, I need to square it. So the next thing I want to do, I want to square this item. Square. Okay. Just try to. I want to square it. So equal this number, square it, and copy down the formula. So I figured out something on the top, the formula. But the formula said you have to add them all, see sigma. Sigma means add them all. So I'm going to add them all here, equal sum. Add all this number together. So that is something on the top in the formula, numerator. Okay, so I get this number. I'm going to highlight this number. Okay, so I got this number. This is something on the top, the result of something on the top. Now the denominator, EI squared, then add them all. So now I'm going to deal with the EI squared. Okay, and for EI squared, I need to add them from 1 to n. 1 to n. So I start from here, equal. Remember, this is my EI. So square it, square this number. And then copy down the formula. After that, see, denominator said sigma. Sigma means add them all. So you add all these numbers together. So I'm just going to copy here. So this means add them all, you see sum. Okay, and once you get that, what is dW? dW, it is just the ratio between these two numbers. The ratio between those two sum, that is dW. Okay, I got that dW. Any questions on how to calculate dW? And
Sorry, can you please have her write back over the formula in column D just for a moment again?
Column, which column?
Column D, so Y hat.
Yeah, it is TREND. And then select Y, comma, select X. The number automatically filled out for you.
So why I'm getting an error message as I scroll down that I'm getting the value is not applicable. What would be the error behind that?
Can you try? So if I redo it here, okay, what if I reproduce column D? So can you make typing equal TREND opening bracket? You select Y. This is my Y, comma. Oh no, I cannot use different cell. This would be, you have to select on the same row. Maybe I want to do it in another cell. I can do Y hat here, okay? So equal trend, select Y, comma, select X, press enter. If you have problem, maybe you want to go to the data, then data analysis. Remember, we did that many times. Get the line equation, and then get the trend. Get Y hat. Okay. The other way I am thinking about, you got the same problem, the data doesn't fit down. Try this. Okay. Try. Before you type in the formula, try select all the range first. Select all the range, and then type in the formula equal trend to see if it will automatically fill down. Okay. If not, you use data analysis, get line equation. Okay. All right. So this is how do we and I showed you the procedure here. Okay, and this is the formula behind. Okay. So if you the same data, you can get the fitted line. See, this is how you can use the equation. See, if you have equation based on this equation, you can calculate y hat. This actually is y hat. You get this equation. Okay. Any questions? All right. So now we know there's a problem with autocorrelation, but how do we solve this autocorrelation? Okay, one way to find a missing variable, incorporate a missing variable, may eliminate correlation. Okay, so this is if original data you have Y is sale, X is income, but this data has autocorrelation. And then you add another variable, unemployment rate, so that you have Y, X1 is income, X2 is unemployment rate to see what happened. Okay. Did I do? I just want to illustrate. I missed one point here. After we calculate DW, this is 0.87. Okay, so this is 0.87. So what? After you calculate this DW, you found the DU and the DL. Remember? You found DU and DL. So how many sample here? What is the sample size? The sample size n equal to 21. Okay. So in this example, n equal to 21. How many independent variables? We have k equal to 1. Suppose alpha 0.05. So we need to find DL and DU. By the way, in our test 2 and final exam, I have no way to type in this subscript L. You may see this symbol DL, DU in the test 2. This represents D subscript L, D subscript U. Okay. So let's find out DL, DU. So K equal to N equal to 21. K equal to 1. So DL 1.2, DU 1.41. Okay. Okay. And where is our test statistic DW? So DW 0.87 smaller than DL. When DW smaller than DL, we conclude positive correlation. There is a positive correlation. Okay. Once you have positive correlation, you cannot use the condition for regression is violated. Okay, so you have to fix this positive correlation problem. How to fix? There are several ways. One way is to add missing variable. So I use this example to illustrate. So again, this data is another, is it the same data set? No, this is another data set. It is about sales and income. Okay.
Professor?
Yes.
I just had a quick question. Can you go back to your Excel document?
Oh, sure.
Because I think you calculated a different Durbin-Watson statistic. Yeah,
you are correct. Thank you for your observation. Yeah, I'm going to double check. Yeah, thank you. This number agree with my PowerPoint, so I need to double check this number. This one is so this one actually is correct, okay? I need to find out why my Excel didn't do correct. I need to find out. Let me double check. Looks like this line has problem. So it is EI minus EI squared. EI minus 1. So this one is correct. F column is correct. The problem with EI minus so I need to check. E. See, I did wrong formula. Should be this one, E3 minus E2. Okay, so I'm going to delete this line. The reason is this one has mistake. So equal to, this is EI minus E2, EI minus 1. Okay, and then I copy down the formula. See, this time is correct. It is just this formula I entered wrong. Thank you so much for your observation. Okay.
Sorry, Professor, can you just show the formula one more time? What was it?
This formula, which formula?
Yeah, that one is
E3 minus E2 in my case.
Okay.
E3 minus E2.
Okay, thank you.
Okay. Any other questions? All right. So this time agree with our result. Okay. So this number 0. Yeah. Okay. So all of this is correct. Okay. All right. So example 8.3, we are trying to solve autocorrelation problem by adding a variable. So this time I want to use SPSS to do it. Okay. To see if we can. So this is example 8.3. So you can copy and paste from Excel to SPSS. Example 8.3, maybe I open, there are way too many windows. Okay, never mind. I will go into open a data file. So that data file is 8.3, chapter 8, 8.3. Okay, so I will delete this one. So this is original data file. You can compare with the this is original data here. So we have sales, we have income, we have unemployment rate. Okay, so once we have those, you can produce regression, okay, and get the result. Okay, and SPSS will give you Duban-Watson statistic here by check out this button here. So what you need to do, you go to analyze regression linear. Okay, so you get this one. Dependent variable is the sales. Independent variable is income. Okay, so let's do two situations. Situation one, if you only have income, what happened? And then if we have both income and unemployment rate, what will happen? Okay, so if you only have income, and then if you quick statistics, you check out Duban-Watson test. Okay, check out Duban-Watson test. Anything else do we need? Yeah, it's just Duban-Watson test. Okay, and then I'm here. You click continue and click OK button, and you will get this result. Okay, so I already pasted this result here. You will get this result, and in this result, you see the Duban-Watson test is 0.722, maybe a little bit small, 0.722. Okay, and this example sample size is 17, K equal to 1 because you only have income. You can find out, suppose alpha 0.05, you can find out DL 0.87. Make sure you know how to find out DL and DU. Okay, so it will be both on test 2 and final exam, how to find DL, DU. And then Duban-Watson test is 0.722. And this number is, there's a typo, okay? This number is smaller than DL, 0.7 smaller than DL. When DW smaller than DL, there is a positive correlation. Okay, so when you only have the income, say you only have the income, you have a positive correlation. So the linear regression model is not fit. Although you see here, p-value smaller than alpha, you say, aha, good. P-value smaller than alpha, the model is significant. Actually, the model, one of the assumptions of the model is violated. So you can not use linear regression. The reason is the Duban-Watson test, you get a positive correlation. Although it said model significant. This is this conclusion suppose the condition is met. Actually, the condition is not met. Okay. Is there a formula for DL, DU, or do we only need the chart? Matthew, thank you so much for answering that question. Thank you for who is asking that question. Okay. Yes, you only use chart. There is no calculation formula for DU, DL. Okay.
Professor,
Yes.
can you show us one more time how to get the Durbin-Watson statistic from SPSS?
Oh, thank you so much. Yes. So you just do the regular linear regression, go to analyze, regression, then linear. After that, you put cells into dependent variable and put income into the block 1 of 1 or independent variable, depending on what version of SPSS you are using. To get Duban-Watson test, you click statistic, check out Duban-Watson. Check out DW here, that's it. You click OK, and you get this output. Okay, any other questions? All right, so we cannot use linear regression for this one. Now let's look at the second situation. We incorporate a missing variable. Now we are going to add another variable. So I'm here, I cancel everything, I reset everything. So now I'm going to do regression with two variables, two independent variables, but dependent variable stay the same. Independent variable, I have two. You press and hold down Shift. I have two independent variables. And then check out Dubon-Watson, continue, okay. So this is the output, okay. And this time, my Dubon-Watson value is 1.98, 1.98, okay. So I'm going to go back to the output. This is my output. Dubon-Watson test is 1.98. This time, remember I have 2x, so k equal to 2. Okay, if you have k equal to 2, you found dl 0.77, du 1.25, dw 1.98 is here, and this dw greater than du. When dw greater than du, no correlation. This is good news. Only if you have no correlation, then you can use regression. So this time, this p-value is a true p-value. The model is significant, okay? And you can produce an equation based on coefficient here. So the equation is y hat equal to negative 0.014 plus 0.03 times income. Maybe our consistent, I use y hat, maybe x1, plus this is negative point. It is double check the output coefficient. It is negative 300 or point, yeah, negative 0.35, okay. Negative 0.35, negative point, maybe I write down clearly. So y hat equal to negative 0.014 plus 0.3x1, negative 0.35 x2. This is x1. So this is equation. x1 is income, x2 is unemployment rate. Okay, so this equation is appropriate. All right. So any questions? All right. So this is one way to eliminate autocorrelation problem by adding missing variable. Next, we are going to use another method to eliminate autocorrelation problem. This method will do difference. We are going to do difference. So this example is on page 350. It's on 350. You have theoretical work, but let's look at the data. This data is the sales. Is sales data for sales from 1976 to 1996. Okay. Again, you have sales value and income. Sales value, income. If you produce regression line, you will find there is a correlation. How do you find out? Use the same procedure as I did for this question here. Okay, perform exactly the same procedure. You found dw, then compare dw with dl/du. Okay, so you found the correlation. So to eliminate correlation, of course, you could find a missing variable, but we already did that. We want to find a new method. This new method is to do the difference, or using other data manipulation techniques. Okay. So for this one, we actually, so this Let me see. So this one, we actually to not directly do difference. We take a logarithm function for sale, then we take a logarithm function for income. Okay. After that, we conduct a regression. So how do you do the log ln? I will show you using Excel. So this is the example. After this one, we take a break, okay, in case. So this is example 8.4. So this is original data, okay. So to do that, I'm going to maybe just copy and paste. So this is 8.4 demo. So how do you do ln sales? How do you do ln income? So you do this. It is take natural logarithm. So in Excel type equal ln, that's it. Equal ln, select B2, closing bracket, enter. Okay, you get 8.1. Do the same thing for income. Equal ln means take logarithm, then quick cell C2, and then copy down these two numbers. Okay, and then copy these two columns into SPSS. Copy these two columns into SPSS, and you will get this number here. Okay, so hope you understand how do I get lny, lnx. I just showed you. Then copy data into SPSS, and then conduct the regular linear regression. So use lny as dependent variable, lnx as independent variable. Select Duban-Watson test. After that, you get DW value 0.498. And this data size is 21. We have just one independent variable. Look up the table, you found DL 1.22, DU 1.42. Our test statistic, there's a typo. Our test statistic is 0.496, 496. DW 0.496, and this number smaller than DL. When this number smaller than DL, there is a positive correlation. So this regression is not appropriate. Which regression? Remember, you take ln y, ln x, okay, is not appropriate. So what do you do next? You do the difference. Next, you do the difference. Okay, so this is you do the difference. How do you do difference? You use, I'll show you in Excel. So we did that. After that, you do the difference. So I want to keep the same location. Mathematically, we use the change. So I will use change. Change of ln y. So what does mean change of ln y? I can start with here or maybe start with here, doesn't matter. So what is the change? So use this is y. Okay, so use this number minus this number. That is the difference. Do the subtraction. Okay, so I put result here or here, doesn't matter. So maybe here, equal this number minus this number. That is the change. Okay, and do the same thing for change of long x represent income, so equal to E3 minus E2. That is the change. Okay, after that, copy down those two numbers. And then copy this number into SPSS. Copy this number into SPSS so that you have this number here. I copy them into SPSS and use this is Y, this is your X, this is your Y, this is your X, and check out DW, you will get this result. Okay, you will get this result. So this result, in this result, you have Duban-Watson DW 1.3. Okay, DW equal to 1.3. And then you need to find out what is DUDL. Remember this time, it is actually still the sample size should be, so let's look at here. So this time sample size is n equal to 20, not 21. See here? So n equal to 20, k equal to 1. Suppose alpha 0.05, we need to find out DL, DU. So go to the table, okay? Go to the table. Here, not here. Here. So K equal, N equal to 20, K equal to 1. So this is DUDL 1.2, 1.41. And our DW between DU and DL. When you have DW between these two numbers, inconclusive. That is a rule of Duban-Watson test. So DW between those two numbers, you don't know if they have correlation or if they don't have correlation. Okay, but our autocorrelation chart, okay, but although it is not inclusive, but you can check the autocorrelation for the residue, okay, that is inclusive, but autocorrelation functions. So autocorrelation functions, okay, shows no correlation. Okay, this is on page, refer to text page 353. Okay, and also from this, we see another problem. The constant is 0.4. So constant is not significant. Means we can drop the constant. Constant is not significant, means we can drop the constant. Okay. So this time we do not include constant. How do you not include constant? You go to the options. After you select dependent variable, independent variable, go to options, you do not select, do not click the check mark, nothing here. See, include constant. Then you run this model again. So after without constant, this time you have Duban-Watson test 1.2. It is still inconclusive, but you can produce ACF function. So this is ACF function. This function shows there is no correlation. If this function like this graph like this, there is correlation. All the bar, all those bar are within this upper limit, lower limit. That means without correlation. Okay. So that is that means we can safely use the model. So this model is good. Where is my model? So the model is based on coefficient here. So this model, if you write down this model, it should be, remember that model is the difference, okay? So the coefficient is 1.01. This is the coefficient. So the model is this one here. B1 is 1.01. This is our model. This model get from SPSS B1. We know we get that model because we take the difference. It is actually this one minus this one equal to. Then you do a little bit mathematics, move this one to the right. You get this one here. Okay, once you get this model, you can make a prediction. For example, how do you predict sales for year 1997? Okay, and you just plug in this t equal to 22. Originally, you have sample size equal to 21. Now you want to predict the next year, you just do this one. Okay, and once you get this one, you get the number you get, it is a logarithm function. You have to return back to what exactly is y. Use the exponential function. Okay, use exponential function. Okay. So that is, this example illustrates we can use data manipulation. We can take logarithm. After that, we did the difference, and then autocorrelation problem disappeared. After that, this model is a fit. This model is a good model. We can use this model to make a prediction. Okay. All right. Shall we all take a break? Maybe 10 minutes break. Come back at 7:40. We are going to continue. Okay. So I'm going to stop recording.